All right, so today we're going to look at Chapter 5, which is all about application security. We're going to talk about some simple things like securing your browser. And these are all things that you as computer people should definitely know, and you probably do. But the other side of this too is the whole user experience and educating your users on these things. Like if they click on something and it's an invalid certificate, not to hit accept and go on through it and things like that. We'll talk a little bit about securing other apps. And then we'll talk just a little bit about secure programming. Now, some of you, based on what your major is, I assume most of y'all are probably networking and security, but we do have a secure programming class that you may or may not take later if you're really interested in coding. So, one of the things that you will do as as an enterprise level admin is probably implement some browser policies. And these may be a couple of things. They might be configured with a server where they are enforced, or they might just be something that's done by HR. And these will include things like a use policy. If you're dealing with a lot of tech people, it will probably have whether you allow the use of Flash or not, some things like that. And the reason that it's a mix of things, you may have technology in place that says, I want to allow this stuff to run. Like you can have a content filter on your network that'll just filter the Flash out. Or it may be something that you say, the internet is to only be used for business so that people have access if they need to Google something for their job, but you're specifying, okay, no, don't spend your day on Facebook or whatever. So one of the things that is unfortunate but is the way of the world, because Internet Explorer and Edge are written with, with Windows, they're written by Microsoft, there are easy snap-ins that are built into them for the group policy that we looked at last week, where you can do group policies to prevent things from running. Like it's very easy to set IE where it won't run Flash or it won't run Java. That's just a click. And if I set the machine where you can't install software, so you can't put Firefox or Chrome on it to go around it, that may be a pain and it may be something you hate, but you see the security side of that in that I have blocked that browser down to keep anything from getting into my network. There are a couple of labs that you can look at this. There's one with IE, the security settings, and the local computer policy that are group policy objects you can use to control this. How many of y'all have installed a server, Windows Server on anything? Have y'all even played around with it? If you install Windows Server on something and you go in and look at Internet Explorer in it, you'll notice that every single site you try to go to is blocked. You have to hit accept to go through it. And that is an absolute pain. But the reason for it is security. They don't allow any connections anywhere with the browser till you go in and explicitly allow them. While that would stink for everyday use for a server, that's kind of a good thing because nobody's going to be connecting to a site. You shouldn't be browsing with a server anyways. So that is just an added level of security. And again, with those, there's an optional lab, but you can look at that those can be done with group objects. So I may lock a browser down for some users and not for others, based on, again, what it is I'm going to need my users to do. So this is not really a thing that matters as much anymore, but this used to be a bigger deal with browsers in the earlier days. You really should close a browser with Alt F4 instead of clicking on the X in Windows. And the reason for that is sometimes if you're closing the X, you may not actually be shutting the browser down. There used to be server-side script attacks, for example, that could open a web browser and minimize it and hide it over to like just the little bar where you don't have a window. So you hit the X and it's still running in the background, so it may still be doing something. There is a website, I don't remember the exact name of it, but I'll find it for y'all, that has all of the Windows update screens on it. And it's something that you might use in an attack because you could have that open full screen in a browser and your machine will look like it's running a Windows update, and in the background it can be doing all kinds of things. In fact, it's been running in here on a few machines here and there, and really the only way you know by looking, if you're not touching the keyboard, that it's not a Windows update is it doesn't stop at 100%. So if you ever see a machine in here that says it's running Windows updates and it's 200% complete, you can assume probably Bruce has done something to one of them. But there are lots of things like that. And, you know, the other piece is use HTTPS. You don't want to think about your admins as watching your traffic, and generally they don't. Like here at Northwestern, you hit the banner message and you agree to that they can monitor your traffic. They don't have time. They're not concerned about what you're doing on Facebook. There's too much going on this network. But you never know, and this is why secure communication is important. Most traffic now is encrypted. Almost everything has got encrypted certificates. Even if you just go do a Google search now, that's encrypted traffic. So make sure that it's using HTTPS. But you should check those certificates and make sure they're valid. You know, you don't want to hit OK if it's an unsigned certificate, unless it's a very specific reason. For example, the only time I'll accept an unsigned certificate is off my own servers. And the reason for that is I didn't want to pay VeriSign $50 to get a certificate that's valid for me to log into that router and check on things. But the truth is that's a security risk. I accept it. I really should just pay VeriSign, and then it would be a secure certificate. Also use a proxy and a content filter. Proxies are great for filtering things. Based on what kind of you know, data you've got coming in and out, or what you're going to allow your users to do, you may have content filters that block certain things. I do not know. We have one of some type here at Northwestern, but there's very little that we block on the network. An example of one that is going to be a lot tighter is like over at LSMSA. And there's a federal law that if you have internet connectivity for minors, which, you know, any high school or anything's dealing with, you have to have a content filter that you know, filters out a bunch of things. And the way these work with proxies, they're normally at the edge of your network and all the traffic goes through them. They might be a server, they might be an actual hardware device. I've moved them now, but you remember the Barracuda boxes that were sitting in here. One of those was a content filter. And what they do, some of them, those have two network ports on the back. You literally put it at the edge of your network going out onto the internet, and you run the traffic through it, and it looks at all the traffic, and it just blocks things as they're coming in or going out that shouldn't be allowed. How many of y'all know how a proxy works on a network? Do y'all remember that from the networking class? Anybody not remember it? You're good on proxies. All right. Proxies add a huge amount of security. They just do, even though it's an extra step for an admin to deal with. You generally want to use like a transparent proxy so your user doesn't have to do anything to configure it. And then, you know, secure against malicious code. What do you need to run? If you don't need ActiveX running for anything, turn it off. Don't let anybody run it. I'll even say the same with Java and JavaScript. Now, lots of people need it. There's lots of things that use it. But if you don't need it, turn it off. That's one less hole that you're leaving in your network for people to get into. Flash is a very interesting one because there's still a lot of Flash out there, and Flash has always been notoriously insecure. They are slowly phasing Flash out, but it's kind of like COBOL. It's just going to linger forever. So, you know, that'll be interesting to kind of keep up with in the future. And then just, you know, there's a lab for y'all to look at talking about proxies. And it's setting up a web browser using a proxy. Now, this one's not a transparent, but it'll show you how you have to go in and set it. And in the old days, this was one way that you could block internet access for certain users. I might, for example, have a proxy running on my network, and I would only go onto the machines that I wanted to give internet access to, and I'd give them access to the proxy. So that way, not everybody could get on the internet. Only the IPs that I allowed through the proxy could get out. Generally, these days, that's not done that much anymore because almost everything's on the internet. All right, so basic browser security. Keep the browser updated, and notice they put if the company policy permits it. Again, based on what I'm allowing you to do as an admin, I've got the rights to control whether you can do these things or not. Generally here, for example, we push updates out. You can't install Windows updates on your own on any of the machines really outside of this room. They get pushed out when they're ready for them to go out. They say consider deferring future updates until you're ready to implement them across the entire network. The jury's out on whether that's a good idea or not. Generally, I'm from the school of thought that you never push an update out to an entire network of this size at one time, because what if that update crashes everything? And I'm going to use an example I've said to y'all before, but some of y'all that have had other classes in here with me, we had an update in here run on Windows, and it crashed every machine in this room. Luckily, this is only 11 machines, but imagine the drama had that happened across this whole campus. You know, everybody comes to work Monday morning, and every machine on campus is blue screened. It would be a nightmare. I know that what they do here with a lot of updates, especially the non-critical patches, they send them out over in Roy Hall first. They send them to the faculty, the staff and all that's over there, and see how that runs a few days. And after that, they'll push them out a little bit more at a time. That way, you know, should something happen, it's not the whole campus they have to deal with. Install a pop-up blocker. There's no reason to not have pop-up blockers at this point. I've mentioned it before. I like uBlock Origin, but there's tons of other ones that are pretty decent. And you can look at considering security zones in your browser. Those are generally an IE thing, but a security zone does add some security. Again, I've said it a lot, and I'll continue to say it. I'm not a fan of Edge or IE, but from a standpoint of security, they're just better than the other browsers because of the controllability you have over your users. Now, that being said, I'm still not going to use one of those on my home machine, but my home machine is not part of a corporate network that I have to worry about. And then be aware of what a cookie is. Most of y'all have had a web class or two at this point. You know that a cookie is something that stores information on your machine. It includes browsing habits. It might be credentials. Cookies can be stolen. That is an issue. Understand the differences between a tracking cookie and a session cookie. Other things to be aware of are locally shared objects. These are usually Flash-based things that are stored on the local computer. If you're playing an Adobe Flash-based game, for example, normally it'll download the Flash file and store that in the cache on your machine instead of it being out there, you know, on the web and pulled every time. The issue with that is I could write some code that's malicious in there, and if you don't close all these browsers properly, I can set that to run maybe later. You just wander off, which I'm world's worst about doing, wandering off from my computer, leaving everything open. So LSOs have you know, they're used by a variety of websites to collect information about browsing habits. The question again is always, why do they want to collect your browsing habits? Why do y'all think that is? Exactly, money. They want to know how to target ads for you because that's what it's all about these days. Let's take somebody like Google. Google has a great, great number of services that I use and like. Google's bread and butter is ads. They make their money by targeting ads to you, and the way they do that is by going through everything that you put on them and looking for things that are related to it. If y'all want to do a fun little experiment, create you a fake Gmail, whatever, then create you a Facebook tied to that Gmail. Then send your fake Gmail account some messages that seem very targeted, like, I need to go to the grocery store, or I want to buy a computer desk, and wait 3 days and go log into Facebook. And magically and mystically, you're going to see ads for computer desks and movies, and that's how they make their money. And it seems crazy because you're like, nobody would click on it, but think about how many people use those services. There's an actual formula, and I don't remember it, but basically, it's if 1% of the people see it and 1% of the people click on it and 1% of those actually buy something with it, I've still made more money than it cost me by far for that ad for that one person. And occasionally, you know, I'm even guilty of it. I'll see something on Facebook. I'm like, that looks kind of cool. I'll actually click on it and see if it's something I want. People do it. People buy things like that. So Flash can be disabled in most modern operating systems. And, you know, it's one of those things where I use Flash for some things, but Flash is not as secure as it needs to be. Another thing to be aware of are ActiveX controls. There are quite a few things, unfortunately, that are IE-based that use ActiveX controls. And unfortunately, you know, you have to have them on for those things. I generally, as a rule, my advice is stay away from ActiveX if possible. And the reason is not only because of ActiveX security, but if you are tied to ActiveX, you're then tying yourself to using IE, which means you're incidentally tying yourself to an operating system. So you can't do a lot of that stuff, you know, on you know, Linux or on Mac or anything else because they just can't run IE, so they can't run those ActiveX controls. In fact, that's what Java's original answer was. Java was built to, or you know, JavaScript was built to be the answer to everything being ActiveX. And then the advanced browser security. There's an advanced tab. By default, that's on a server. Again, it's good and bad. It locks the browser down tremendously, but it adds a layer of security because people can't use it. Other things to be aware of, user account control. Anything Windows Vista or newer has this. And what that does, this is very much a Unix idea, a Unix-Linux idea. Basically, when you are on your computer in normal use, you are not an administrator. You are locked down. UAC is that pop-up that comes up that says, do you want to allow this software to run? You know, you need to be an administrator to control software. You really should never turn that off. That is a good thing to have, even though it's a pain. Because what we're doing is by making our user run as a normal user and then only becoming an administrator when we need it for something, we're adding a layer of security. In the Linux world, this is the idea of the SU or sudo. You're normally a user, and then SU is super user. You become a super user when you need it for some specific thing. But you generally don't run as root all the time, which root is their equivalent of admin. You don't run as root all the time so that you are not in that mode and accidentally do something. The only exception to that really is Kali Linux. Kali Linux is the last one that you log in as root on. And you really shouldn't be using Kali as a normal operating system anyways. I mean, you can. It's got all the features, but you don't want to use Kali except for, you know, when you're trying to do something specific with it. So other things, basically just keep your, keep all your software patched. They put Outlook on here as an example. Install the latest service pack. Increase the junk mail security level. Password protect your PST file. That is the database that all your local email is in. Consider encrypting a login. If you're logging into an Outlook, an Exchange server, or into Microsoft's Outlook.com or Hotmail or any of those, it's going to be secured anyways. Other suggestions for Word: you can use a password to open or modify a document. I think those are good. Word and Excel passwords are great with files, and they've kind of upped their game though. I'm going to tell y'all that Word and Excel now are using good AES encryption, and the plus to that is yes, you'll secure that document, but the minus is if you forget that password, Microsoft can't reverse engineer it. You're not going to get it back. When you start dealing with true encryption, which we'll talk a lot about as we move forward, once you encrypt something, the idea is always it's better for no one to have it than the wrong people. So if something happens, you'll lose the data. So I'll go through this pretty quick. The software development lifecycle, y'all have all had classes on it. There are phases of the SDLC: planning and analysis, software, implementation, testing, integration, deployment, and maintenance. The principles from a secure standpoint are things that we've talked about before. The principle of least privilege. Only give the user the least amount of privilege they need to do their job. When it comes to software, write it so that they are locked down and they don't have access to things they don't need. The principle of defense in depth, which is kind of along that idea. You should test every piece. You really want to have users get out there and try to break it. especially in a like a beta environment, in a closed environment, because it's much easier for you to fix things before they get out in the wild. If there's a problem. Applications should never trust user input. That's one of my favorites. There is an old type of attack where you can send an SQL command to a database in an input field, and some databases will accept that. In fact, I read an article just recently that I thought was the most hilarious thing I've ever seen, and I'll try to find it in a minute to share with you all in the class. But you can Google this. Somewhere in England, a guy figured out the fields in a database for the cameras that capture your license plate, and he put an SQL injection attack on the front of his plate and drove down the street, and the camera picked it up and he deleted their database. Now, I imagine he went to jail. I don't know, or they hired him to fix their crap, one of the two. But, just as a crazy example, those things happen. There used to be a meme on my desk for a long time about a kid named Little Bobby Tables, Little Bobby Delete Table, and, the whole idea of that you should sanitize your databases because his name deleted the database. Minimize the attack surface. The less places you have for, attack, the better. This goes from a network side of closing all your ports and all of that stuff. Fail securely. Problems do happen. Again, you want to do all the testing you can. You want to make sure that if you have a memory leak or anything like that, or if there's an overflow in your software, that it shuts down as graceful as possible. And security issues are going to pop up. You've just got to fix them as quickly as possible. So when you are a systems developer, you should always keep that CIA triad concept in mind. And if y'all remember that, it's confidentiality, integrity, and availability. From confidentiality, only allow users to access the data which they have permission. You really want to segregate things. Just as a crazy example, if you've got one master database and it's got HR records over here and medical records over here and user data here, those should all be separate. Not everybody should have access to HR or to medical or whatever. From an integrity standpoint, you want to make sure your data is not tampered with or altered. You want to have some kind of checksum mechanism, be it a hash or something else, to make sure that it's there. And from an availability standpoint, you want to make sure that users are authorized and can get to it. So the CIA concept is just important when you're writing secure code. There are a couple of different types of testing that you can look at. Black box testing is where you have users that don't know anything about your system test your software. White box is where you give them some logins. So this is something that would be more internal. They know how to log in. You want them to log in and look at it. Both of these are useful for different things. Sometimes it's good to have someone that knows nothing about your system look at it. In penetration testing, we talk about the same thing, a black and a white box test. And sometimes having a user that knows nothing about your system is a good test subject because they're testing it, they're hitting your system just like somebody on the internet would. At the same time, having someone also test it from inside is good as well because most threats now actually come from the inside, not the outside. It's disgruntled employees that let someone in and things like that that are a lot more of a threat than stuff coming in on the internet. And know the differences in your compile errors and your runtime errors. A compile error is when you've got a syntax error in your code. A runtime is when you have an error after it's running, something just crashes. And then input validation. Always make sure that they, correctly input their data. That's where the little SQL stream I mentioned comes in. You just want to make sure that your data is validated, that you're checking for things like that so that users can't do anything they shouldn't be able to do. You also are going to want some code analysis. Static is a type of debugging where they examine the code without executing it. Dynamic is where they execute it when they're testing it. These are both done when you put any kind of app on the App Store for Apple or Android or even the Microsoft Store. That's why they charge you the money they do, because they're going to run your code and look at it. It's kind of their job to try to make sure your code is not doing anything it shouldn't do. And then a fuzz testing is where random data is inputted into a computer to try to find vulnerabilities. Basically, if I've got a database running, I might fuzz test it by sending as much data as quickly as possible to it just to see what it does. So other things to be aware of. A backdoor in a piece of software is a way to bypass authentication mechanisms usually in place. These had an original good purpose, but not anymore. They're really not used for what they were intended for. In the old days, for example, if I wrote a piece of code, I might put a backdoor in it so that if you locked yourself out, I could log in as the master administrator with whatever my code was and fix it. The problem is if someone else figured out how to do that, they could log in and do the same thing. So, it's just something that happens. You can't, if you are a BIOS company, for example, you're making BIOS, you're AMD. Somebody might put a backdoor in a piece of code and you don't find it till later. So then what you've got to do is send updates and make sure that all your people that are using your stuff know. So the way you can kind of avoid backdoors and security errors, keep your firmware relatively updated. I've said this, I think in y'all's class, maybe it was CH class, but I have a general rule that I won't update the BIOS on a machine unless I need to or unless it's a security fix. But if they release one that's a security fix, you click on the README and it'll say this is a security fix. In that case, yeah, go ahead and run it. Windows updates, I know there's a lot of them, but especially the security updates, you really need to run. They're there for a reason. Normally, there's a problem, and you're correcting that problem is the reason you're running them. A buffer overflow vulnerability. A buffer overflow is when a process can store memory outside of what the developer intended for it to store memory in. These can be very big problems. For just an example, there have been a couple of instances where people have been able to use a buffer overflow to get information outside of a virtual machine into another virtual machine. And think about that if you're running a server with multiple virtual machines, the vulnerability that's created there. And then arbitrary code execution is where an attacker gains access to the computer through some sort of vulnerability. Generally, this gets more into the CH class, but you try to get code to execute that will give you some sort of privilege escalation. I manage to get on the computer and I get a command prompt. Well, then I want to make myself an administrator so I can really do some things. So I figure out a way to execute some code that will let that happen. Other ones to watch, cross-site scripting and cross-site request forgeries. These are just vulnerabilities in browsers. Other ones to be aware of, an SQL injection. We just talked about that with that little example. XML injection. I'm not super familiar with XML, but apparently it's vulnerable to an injection as well. And an LDAP. LDAP is the Linux version of Active Directory. There are some types of injection that can take advantage of those. Most of these can be closed by, if you don't need things, just turning them off, and by setting passwords. If you are running MySQL, which is one of the popular databases on Linux, and Windows versions too, don't leave the blank, don't leave the root password blank, which is what it's set up as. Little things like that that you just need to do when you set this stuff up. A directory transversal. This is where I have access to one directory and I manage to get access to directories above it by some kind of access, usually privilege escalation. Thinking about Windows, for example, how many of y'all are sort of familiar with the way Windows files are? You've got your users directory and you've got access to your user directory. But if you manage to gain, privilege escalation of any kind, you can go up from the user directory and see the other users, and you might be able to go into their directories and see their files. In Linux, that's the root directory. You have a home directory that's your stuff, but all the other users have their own home directory. And then a zero-day attack is something to be aware of. This is a vulnerability that is executed before the creator of the software it's on, like Microsoft for an operating system, before they get a patch out. These are the worst types of attacks, and these are the ones that honestly Not to scare everybody, but there's very little you can do about. Usually a zero-day attack is something that somebody figures out and they release it, and then the companies have to scramble to try to fix it because there's an actual vulnerability that's out there in the wild that now hasn't been fixed. With Microsoft, you can almost always count on it being a zero-day attack when a patch comes out, not on a Tuesday. If they release an update like right away, like Wednesday, there's a security update, you can almost count on that there was some weird zero-day attack that they've just gotten word of and they have scrambled to fix it. So there are 12 true false and 12 multiple choice with this chapter. And the labs are pretty good about some of the stuff with like group policy and IE. Those are things that you're probably not going to do on your machine, but would be good to know for you to know how to do. You might want to do them in a, in a more corporate environment. Again, review the topics. Look at the real-world scenarios. They say this. I'm sure you all have at least Firefox or Chrome, if not both. I keep both on my machines. The new Firefox I'm kind of fond of. It's pretty fast. I've always been a fan of Chrome too, though. One of the Chrome's features that is good is also bad. Chrome compartmentalizes its memory, which is great if you've ever noticed. How many of y'all are Chrome users? If you've ever noticed in Chrome, if one window crashes, it doesn't crash the whole thing, which is awesome, but that means every Chrome window uses its own piece of memory. I have 32 gigs of RAM in my machine at home, and I've seen Chrome use 30 gigs of RAM because I've had, too many windows open and haven't closed things, which is my own fault. Firefox is a little better at managing memory, but because it doesn't compartmentalize things, nor does, IE for that matter. When a Windows crashes, like if Flash crashes in a window, Firefox crashes. You lose all the windows. So it's a playoff there. And that will conclude Chapter 5.